Hello everyone. In this video we will discuss about memory management techniques. Okay, how memory is managed in the operating system, that we will be discussing. How allocation is done for the process or a program which has to be executed. Okay, so this memory allocation is of two types: contiguous memory allocation, memory allocation. But the name is so we are understanding that it is a continuous memory allocation and it is a non-continuous memory allocations. Single portion will be allocated. Whereas here memory can be allocated anywhere in the system. Okay. So in continuous memory allocation there are two types: fixed partition allocation and variable partition allocation. Okay. Partition allocation, which is also called as static allocation. Okay, fixed means static. Okay, it is already fixed, it cannot be changed. Okay, whereas here variable partition allocation means dynamic memory allocation. Okay, so in this video we will be discussing about these two types. First one is fixed partition allocation. Okay, it is the easiest memory technique. Okay, so in this method what happens? See here, my program. See, let us say that I have some 5 programs in my hand and I wanted to execute these 5 programs. So when I wanted to execute these 5 programs, I will fix the portions. Okay. So if I have some 5 portions, then I will fix 5 programs, 5 blocks at a time. Okay. 5 programs which have to be executed. So I will fix up all 5 blocks at a time. Okay. So here what is fixed? Blocks are fixed. 5 blocks are fixed for my 5 programs. But in this portion, the size of the portion is not fixed. Our portions are fixed, but not the size of the portion. Size portion is of can be any size. Like first portion is of 10 KB, KB. Here in fixed partition allocation, I will fix the blocks or portions. Portions here, but size of the portion is not fixed. Okay, so in this method what happens? All types of computer memory except a small portion which is reserved for the OS is available for one application. So here there are 5 applications for which I have reserved 5 memory blocks, okay, which is of different sizes. It can be of different sizes or it can be of same size. But here the fixed thing is 5 portions. This is nothing but fixed partition allocation. As here blocks or portions are fixed, this is static memory allocation. Okay. And coming to the set, this is the theory part of the fixed partition. You can take a screenshot of this. So always what happens? Multi-programming. Operating system has to support multi-programming, whether it is a fixed one or any other thing. Okay, multi-programming means CPU should not sit idle. Okay, every second some or the other program have to be executed by the CPU. Okay. So multi-programming with fixed partitioning is a continuous memory management technique in which the main memory is divided into fixed sized partitions which can be of equal or unequal sizes. Okay. I will look up the portion. So if I found this portion 10 KB portion, okay. So let us think my program needs some 20 KB block. So I will leave this because it is of only 10 KB. I will go to the second portion. It is of 30 KB. So my program needs only 20 KB. So I can take up this portion, okay, which is big enough. Remaining 30 KB will be wasted. That is not my concern actually because my program needs some 20 KB. So I will take up this second block only, which is big enough for me. Okay. If there is no free space available, then the process waits in the queue to be allocated memory. It is one of the oldest management technique which is easy to implement. If I don't find any space in this, so my program will be in the ready queue only until it finds the space. Okay, and in very olden days like 1960s, 1950s, because that time mainframes are used. So each layer is called as frame. So their mainframes are used. So that is why this fixed partition allocation is needed. And that time only few programs are there. Many people did not use this system for running programs. So only few programs will be there. So for that fixed memory is allocated to the programs. So in olden days it happens. The second one is variable partition allocation. So in variable partition allocation, what happens? Space in the main memory is allocated strictly according to the need of the process. This is the theory part. You can take the screenshot of this. We will go with an example now. Okay. So here in the variable thing, what happens? Variable partition allocation. Let us think. See here, this is the block. Okay. This is the. Let us think. This is the memory space. To free. Okay. So I have some four programs in my hand. Okay. Or four programs in my hand. My first process needs. I found that my first process needs 130 KB soon after going into the memory location as it is of 130 space. As my process 1 needs 130 KB, I will take 130 KB itself. Okay. And my second program needs some 250 KB. After process 1, nothing is there here. Okay, it is all free. So my process 2 needs 250 KB. So I will enter and I will take up this 250 KB space. Okay, here there is no space wasted. Whatever I need, that I have taken. Okay. So here my process 3 needs 100 KB. I have taken only 100 KB. Then my process 4 needs 150 KB and I have taken process 4 also. Let us think that this process 4 is not there. Let us say that process 4 is not there. So till here memory is full. For process 1, process 2, process 3, memory is full. So this process 4 is not there. So in the this memory is also having some space, right? Only this much of limited space. It is not like unlimited space will be given or undefined space is there. Okay, it is will be also having some limited space. Okay, so if I am having only three processes and the process four is not there, this is not used. Okay, because I don't have another process and this and this space I don't want. So it is left free. So whatever I want, I will take only that much space. If something is remaining left over, if memory space is left over, that will not bother me. That is not my concern. It may left free. That is not my concern. Okay, this is what happens in the variable partition allocation. So where whatever the process which is having needs memory, only that much memory is taken. Remaining is left over. Okay, that is same is written here. You can take the screenshot. Okay, this is all about variable partition allocation. These are the two types present in the contiguous memory allocation. Okay, fixed partition allocation and variable partition allocation. So here in variable partition allocation, memory is allocated dynamically. So if my process 1 want to execute, it will be loaded into the main memory, and it has given the 130 KB space, and it will be executed. Okay, it is a dynamic memory allocation. Okay, thank you.